28, we do have to draw these curves and then find the area between them. So we will begin by drawing the curve y is equal to 1/4 x squared. So let us draw just some units here. That's 1, 2, 3. So this is a parabola that opens upwards, but it has been horizontally compressed by a factor of 4. So our points, if we are to plot it in, are 0, 0, and then 1, 1 and 1/4. So over here, and then 2 and 1, 2 and 1. And since it is symmetric, it opens up the same to the other side. And so it looks something like this. Basically looks like your regular parabola, but opens up wider. Now, let's talk about the other function. So this is y is equal to 1/4 x squared. Let's talk about this one, 2x squared. So it is also a parabola, but now it opens up very steep. So we have the point 0, 0, 1, 2, and then we would have the point 2, 8. So it would be very, very steep. This would be our second curve. Y is equal to 2x squared. And we also have the line x plus y is equal to 3. Or we can write it as y is equal to minus x plus 3 for this curve over here. So this is just a straight line. This is just a straight line whose y-intercept is at -3. So it does go something like, whose y-intercept is +3. So it begins here, and then it is sloping downwards. So we have the point 1, 2, 2, 1, 3, 0, and so on. So it goes about here. And it does want us to consider from x greater than 0. So we will be considering this section here, which is the area between these three curves. And let me just write this down, that this is y is equal to minus x plus 3. So now that we have the section, we do have to think about how we're going to integrate this, because we're going to have to split this into two integrals. And the splitting point will be at about this line over here, where I'm drawing the dashed line. Because if we draw a rectangle before it, we can see that the upper curve is the pink curve and the lower curve is the green curve. However, if we draw afterwards, we can see that the upper curve is the blue curve and the lower curve is the green curve. So since we can't express the lower and the upper and the lower boundaries in a single integral, we will have to break this down. So to set up our integral, we do need to find out 2 points, right? First is this point over here, where the blue line and the pink line intersect, and also this other point where the blue line and the green line intersect. So let's find out the boundaries for the first integral. So we are going to set up the pink line, 2x squared, equal to the blue line, because we want to see where they intersect. So we'll bring everything over to the left, 2x squared plus x minus 3. And then we need to factor this. So we are going to factor this into +3 and -2. So this is 2x squared minus 2x plus 3x minus 3. And this gives us 2x, x minus 1, minus, let's see, plus 3, x minus 1, yes. So that gives us 2x plus 3 times x minus 1. And then we're going to set this equal to 0, right? And so we can see that it's true when x is either equal to 1 or when x is equal to negative 3 over 2. We will ignore the negative 3 over 2 because we are just looking at the positive side for x greater than 0. So x is equal to 1 is our boundary. So the first integral, it goes from 0, because these lines intersect at 0, to 1 of the upper curve, which is 2x squared, minus the lower curve, minus 1/4 x squared, and all of this times dx. So once we have this, now let's set up our other integral. So our other integral begins at 1, which is the lower boundary, but we do need to talk about how we're going to find the upper boundary. So once more, we need to set these equations equal to each other. And now we need to set the blue equation, so equal to the green one. So 1/4 x squared is equal to minus x plus 3, because that's where these two curves intersect. So we're going to bring everything over to the left, and we're going to multiply everything by 4 to make it easier. So I have 4x squared plus 4x, then I'll bring the 3 to the other side multiplied by 4, minus 12 is equal to 0. So now we are going to factor this out, and the way that we can factor it, actually this initial one should be just 1, yeah. So we're going to choose the numbers 6 and negative 2 because they multiply to minus 12 and they add to 4. So this is just x minus plus 6 times x minus 2 is equal to 0. So now we just know that either x is equal to 2 or x is equal to negative 6. And then once more, we're going to ignore the negative 6 because we're only looking at x greater than 0. So 2 is the point where they intersect. And now we do need to build up our integral. Let me just erase this so that we can focus on the other stuff. So now our upper function here is the green function. Sorry, it's the blue function. So minus x plus 3, and then minus the green function, minus 1/4 x squared, and all of this times dx. So let's integrate both integrals and then apply the boundaries. So this is from integral number 1, this is 2x cubed over 3 minus x cubed over 12 from 0 to 1, plus this is minus x squared over 2 plus 3x, and then minus x cubed over 12, and all of this from 1 to 2. So let's compute these boundaries. We only have to consider the upper boundary for the first one because the lower boundary is 0, so everything's just going to go to 0. So when we plug in 1 for x, we just get 2/3 minus 1/12. Now let's look at the other one. Let's plug in 2. So this is minus 2 squared over 2 plus 6, and then minus 2 cubed is 8, minus 8/12. Now let's apply the lower boundary. Minus 1/2, which is plus 1/2, and then minus 3, minus and minus, plus 1/12. Let's see. Oh, and I should have done this 1/12 over here. Yeah. So let us simplify things. Let's see. This is 2/3 minus 1/12 plus 1/12. So let me put in a different color. These cancel out. What else cancels out? We do have 2/3, right? Let's see. So this is 2/3 minus 4 over 2 minus 2 plus 6 minus 8 divided by 12 plus 1/2 minus 3. So this gives us the answer to all this calculation is 1.5 or 3 over 2. So that does give us the area between these curves. So let me just zoom out so that you guys can see. And as always, we just drew these lines, and then we realized that we had to break it up into two integrals, right? The first integral is from 0 to 1, and the second integral is from 1 to 2. And we found those boundaries by setting the curves equal to each other.